form, which is the way I think a lot of you will like. And then there's the linear combination form, which is I and j. So if you notice these two, they're equivalent. Okay? 2 negative 3 is the same as 2i minus 3j. So with that thought in mind, what would the component form of negative 7i plus 5j be? It'd be negative 7 and then 5. That's it. Biggest thing to remember about component form, remember the arrows. So anyway, we're going to now talk about magnitude. Now we briefly talked about magnitude yesterday. We've got two formulas for the magnitude of a vector. Basically, the magnitude is the length of a vector. And so there are two ways to symbolize that. The first way is to do q1 minus p1 quantity squared plus q2 minus p2. And you're probably wondering, well, what is that? Okay? And so here is what that is. The magnitude is going to be from point P1, Q1 to point P2, Q2. So P1, Q1 is your initial point. P2, Q2 is your terminal point. All right? Another way that can be viewed is V1 squared plus V2 squared. That's the square root. How solve it?
Outcome looks like the distance formula.
Okay. Now, it does. It looks real similar to the distance formula because that's all it is. Okay? That's pretty much all it is the distance formula in a nutshell. So let's go ahead and look at this. It says find the component form and the magnitude of the initial point and the terminal point. Okay. Find the component form and the magnitude of the initial point and the terminal point. So this is defined as being P1, P2. This is defined as being Q1, Q2. So if we go ahead and find the magnitude is defined as the square root of Q1 minus P1, so negative 1 minus 4 quantity squared, plus 5 minus negative 7 squared. So there you go. All it is the distance formula. So if you get stuck, you're subtracting your x's and then subtracting your y's. That's it. So the square root of negative 5 squared, which is 25, plus the square root of, how much squared? 12 squared, which is 144. Square root of 25 plus 144 is square root of 169. What's the square root of 169? 13. So that is the magnitude. That's it. Think you can handle that?
Yeah.
Yeah.
Why does the V have 2 lines on the side?
Oh, that's just another way to represent it.
Okay.
What?
It's fun.
What's the
So that's cool.
component form and magnitude? Where's the component form at?
Okay, so there's our magnitude. Now what we're going to do is we're going to find our component form. So to find the component form, all you're going to basically do is subtract the x's. And what do you get when you subtract the x's?
Right.
Negative 5. What do you get from the y's? 12. Now I have a question. In looking, oops, I messed that one up. In looking at this problem, here's where the negative 5 comes from. Here's where the 12 comes from. Okay? So that would be the component form. All you're going to do is subtract your x's, subtract your y's. So we have our component form, we have our magnitude. Okay, so far so good? So let's go ahead and look at this one. Find the linear combination of the vector that has initial point 2, negative 5, and terminal point negative 1, 3. So there's two ways to do this. One, you could put it in component form, and then from component form write it in the IJ form. Or two, you could jump right into the IJ form. I would go ahead and find the component form first. So to find the component form, I'm going to start with a negative 1. And I'm going to take negative 1 minus 2. And then I'm going to start with the 3. And I'm going to take 3 minus negative 5. And chances are you aren't going to need to write that down. I'm just writing that down for anybody that's watching the video or somebody that isn't here to listen to the lesson. So what would the component form be?
Negative 3.
Negative 3, 8. Another way to do this in your head, from 2 to negative 1, you've went down 3. Or I take it back to the left 3, which is negative 3. From negative 5 to 3, you've added 8. So that's where that could come from. So if we're writing this in linear combination form, it would be negative 3i plus 8j. And that's it. Now the easy way, if you wanted to find the magnitude, is you could square the negative 3 and the 8 and take the square root. And that would work. So vector operations, really easy. I don't even know if you'll need to write these down. I mean, these are kind of those that are just like, well, duh, that makes sense. If I told you that vector v is negative 2, 5, and I wanted you to find 2v for me, what do you think 2v would be?
Negative
4,
10.
10.
Negative 4, 10. Oops, for some reason, having trouble with the computer there. Negative 4, 10. That's exactly right. All you're doing is taking 2 times vector v.
It's like matrices.
Yeah. Pretty much like matrices, yep. So now we have vector w minus vector v.
5.
Negative 1.
No, 5.
Yep, 5 is right. And then what?
Negative 1.
Negative 1. Because all you're doing there is you're taking whatever vector w is, so 3 minus negative 2, and then 4 minus 5. Now v plus 2w, if I were you, but once again, you can choose to do whatever you want, I would write 2w up here.
Me too.
Funny. Okay, so now if you add that to vector v, what do you get?
We'll get negative
4,
4.
13.
You know,
Okay.
2 great minds think like this. Mine just wasn't as great.
Okay, so that's pretty much how you do vector operations. So once again, pretty straightforward. So let's go ahead and look at this one. Now this one is in terms of the linear combination, so this is in terms of I and j. And so then the question is find 2u minus 3v. It's no different than if we were in the other form. 2u is going to be what? Good. Negative 6i plus 16j. Good. And then what's negative 3v? Negative 6i plus 3j. Now real quick, notice it says minus 3v. So I went ahead and used a negative 3 and distributed that, because then now I'll just go ahead and add them together. And so when you add them together, what do you end up having? Okay, negative 12i plus 19j. Perfect. So once again, we aren't doing rocket science or anything like that. It should be pretty straightforward. Not really. The unit vector. We're going to talk about 2 more things and then we'll be done for today. A unit vector is a vector that has a magnitude of 1, and that should make sense because when you hear the word unit, you should automatically think of 1. So it's a vector that has a magnitude of 1. Now the question is, how do you create a unit vector? What you do to create a unit vector is you start with whatever the original vector is. So this is your original vector. What you're going to do is you're going to divide that by the magnitude of the vector. So you're taking whatever the original vector is, and you're dividing it by the magnitude. Okay, once again, pretty straightforward. So let's go and look at an example of that. Find a unit vector in the direction up. So now what I need to do is I need to find the magnitude of that. So to find the magnitude, that's going to equal the square root of -2 squared plus 5 squared. So if it's written in component form like that, all you have to do is square each of the individual parts. If it's given as two specific points, that's where things are different. That's why we calculated it different earlier. So the square root of 29. Good. So now it says find a unit vector. So to find a unit vector, it was defined as being, okay, vector v, 2, 5, over root 29. Can't leave it like that, you're right. So the first part I'm going to get is 2 over root 29. And my next answer is going to be 5 over root 29. So if you notice what I did, all I did is divide each of the individual components by root 29. So this and this. But as you said, I'm not going to let you leave a root in the denominator. So your final answer should be -2 root 29 over 29, and then 5 root 29 over 29. Now that is a unit vector. That means if I calculate the magnitude, I will get a magnitude of 1. So once again, shouldn't be too bad. We've got one more thing we're going to look at. Okay, it says find the direction angle of each vector. Now I will tell you, this is where you use your right triangle trick. So once again, this shouldn't be anything new. So the first one we're going to look at is 2, 9. So what that means is that you've got a vector here. So if I draw it in standard position, that means it starts at 0, 0, and it goes over 2, and it goes up 9. And there's your vector. So they want you to find the direction angle. So what I want to find is this angle right here. How can I do that?
Oh, the angle.
Tangent. So
Yeah.
tangent of that angle, we'll call it theta, equals 9 over 2. So if you go ahead and calculate the inverse tangent for me of 9 over 2, what do you get? 77.47 degrees. That's it. Now on the next one, this is the exact same thing, except for it's written in IJ form. So if you don't like the IJ form, this is just 3, -4. So if we draw 3, -4, that means this way 3, and then down 4. Now this one's going to be a little different, because we have to look at where we're located. So then now I'm going to do the tangent, because I'm finding this angle right here. So the tangent of theta equals, oops, sorry, I'm going to leave it as 4/3. What's the inverse tangent going to be? $55 point what? Yeah, that's right. Okay, 53.1, is it 19 or 113? So that's what this angle is. Now if you remember when we learned about vectors, they're always measured from the positive x-axis. Okay, so if I put my coordinates in there, I'm measuring actually this angle right here. So what are you going to have to do? Subtract that from 360. So 360 minus 53.13 degrees, and you should get 306.87. And there you go. Once again, shouldn't be too bad. Assignment for Thursday. Page 497, 2 through 30 to the evens, 44 through 52 the evens.